So the last one we were looking at complicated derivatives, simple derivatives of sine and cosine, where we're only doing basic chain rule and such. Now we're going to have a look at a few more interesting ones. So let's have a look at this first one, A. Alrighty, by the previous rules we've learnt, I'm going to teach you a little trick. If you ever forget your derivatives of sine and cosine, you only need to remember one thing. Sine goes to cos goes to negative sine, negative sine goes to negative cos, and negative cos goes to sine. And you get a loop of 4. Now this loop is really useful for remembering, and we're going to be using a fair bit. But the only part you need to memorize is that sine goes to cos. If you remember that, then derivatives become quite straightforward. So cos goes to negative sine. So h dash of x is going to be negative sine of x squared plus 2x. But, chain rule, times by the derivative of this. And the derivative of that is 2x plus 2. Let me put a line of separation. There we go. Alrighty, and so then you might go, okay, well, we're all finished. I would like to expand out these brackets. And these brackets are going to be a little bit interesting to expand. We get 2x plus 2. So when we expand out these brackets, what are we going to get? Well, we've got to multiply this whole thing by that and by that. So we're doing expanding brackets properly because we've got that addition happening there. We can't expand the sine x squared plus 2x because sine is a function, so you can't expand that out, but we can expand it to the others. And so we get negative sine of x squared plus 2x times 2x plus minus sine of x squared plus 2x times 2. Right? First, second term. And this gives us negative 2x sine of x squared plus 2x. By convention, we always write. And then, so in order, we put constants, sine, constant, any polynomial terms, so x squareds, any exponential terms, e to the x's, and then any sine, trigonometric stuff afterwards. Alrighty. Plus minus is just minus 2 sine of x squared plus 2x. Alrighty. Now these are both equally ugly ways of writing it. This up the top is the factorized version of it, right, because we've taken out that common factor. And this down the bottom here is the expanded version. Is one better than the other? Meh, doesn't really matter. It's mostly a choice. Let's have a look at the next one, because the next one's quite interesting. So it's A, done. Let's have a look at B. So B is h of x is equal to sine 3 of x. Now what does the sine 3 of x mean? Well, it actually means sine of x to the power of 3. So when doing chain rule to this, we have to do the power bit first. Alrighty, so let's do h dash. So h dash of x is going to be equal to 3 sine of x to the power of 2. But by the chain rule, we multiply by the derivative. What's the derivative of sine? Ooh, back up to the top to my little loop. Sine goes to cos. Since sine goes to cos, we're going to multiply by cos of x. Alrighty, bit of cleanup to do. First thing, we get 3 cos of x, and then sine of x squared. But wait, I just showed you before that I could write this as that. How could I do the same thing for these brackets here? Well, I could just write it as 3 cos of x sine 2 of x. Looks a little bit cleaner, a little bit simpler. Alrighty, so that's quite a different example. Let's have a look at C. C is an exponential with a trig function in the power. So let's do it. h of x is equal to e to the x plus sine of 5x. Alrighty, so by the most wonderful derivative rule we've learnt so far, derivatives of exponentials is, well, e to the x derives to e to the x plus sine of 5x. But what have we got to multiply by? Well, we've got to multiply by the derivative of that. What's the derivative of that? Well, it's going to be 1, sine goes to cos, plus cos of 5x. Ooh, but I've got to chain rule that, so we're going to multiply by 5. Alrighty, clean up a little bit. E to the x plus sine of 5x times 1 plus 5 cos of 5x. And right here is where we've got a bit of choice. We could expand these brackets out, or we could leave it as is. If we expand out the brackets, we will get e to the x plus sine of 5x plus 5e to the x plus sine of 5x cos of 5x. Alrighty. Right, because when we expand out the brackets, we're just multiplying this by that and that. Alrighty. So some more complicated looking ones. Let's do that last one. Alrighty. So this is our final one we're going to have a look at, which is h of x is equal to the square root of cos of 3x plus x squared. Now this is quite an interesting one. It's actually a function within a function within a function. So the innermost function is 3x plus x to the 5. The next function is cos of x, and the last function is the square root function. So we've got 3 layers of function, which means we're going to be doing chain rule twice. But we're not going to do it all at once. Let's have a look at what I mean. So this could be written as cos of 3x plus x squared, all to the power of a half. Now a half we know how to take the derivative of. So let's ignore everything inside the bracket, bring down the half, cos of 3x plus x squared, a half minus 1 minus a half. Oh, but I've got to multiply by the derivative of the brackets, which is all of this. And cos goes to negative sine of 3x plus x squared. But I can't just do derivatives like that. I need to multiply by the derivative of the bracket, which is 3x plus x squared, which will give us 3 plus 2x. Whew. This is some pretty heavy stuff. Alrighty, so that's the chain rule completed. That is the full thing. This is not a function of a function, so I don't have to worry about chain rule a third time. So, a half cos of 3x plus x squared to the power of negative a half negative sine 3x plus x squared times 3 plus 2x. So it's quite a long, lengthy thing. First thing I'm going to look at is get rid of this negative power. Negative power means it's going to move to the bottom. So I'm going to be left with a half times, and then fraction. On the bottom is going to be cos of 3x plus x squared to the power of a half. And the top's going to be everything else. So that's minus sine of 3x plus x squared times 3 plus 2x. Alrighty, the top's going to get multiplied by 1, and the bottom's going to get multiplied by 2. Alrighty, we're nearly finished. A bit more cleaning up that we could do, and then we're all done. So the bottom we'll clean up first, because the bottom's quite easy to clean up. I don't like to the power of a half, I'd rather a square root. So 2, and then the square root, well, cos of 3x plus x squared, take the square root. Alrighty, the numerator on the other hand, we're going to have to expand them brackets. So if we want to clean this up, we are going to have to expand the brackets. Okay? And in order to do that, we're multiplying sine by 3 and then multiplying sine by 2x. So we get negative 3 sine of 3x plus x squared minus minus 2x sine of 3x plus x squared. So those are some really tough examples of derivatives with sine, cosine, exponentials, square roots, and everything. Some really tough examples to have a look through. My suggestion, have a go at a couple of these ones, see how you go. If you're having any trouble, make sure you ask for help. Alrighty, I'll see you in the next one. Goodbye.